this way. Y such that y is an element of all real numbers except y does not equal 0. So you can write it several different ways. Okay? And our last function that I want to go over is the radical square function, which is similar to that one, with one important difference. We have 1 over x squared. Now we saw with the quadratic function, once you do that x squared, it doesn't matter what you put in for x, it's always going to be a positive y. So let's look again at -2, -1/2, 0, 1/2, and 2. If I do -2, I have a 1/4. When I do a -1/2, it's like 1 over 1/2, -1/2 squared. And so that will give me a 1 over 1/4. When I square this, the negative will go away because a negative times a negative is positive. And so that's just like saying 1 times 4 over 1. So this will equal to 4. The 0 again cannot exist. You can't divide by 0. 1/2, I followed the same logic and I get 4. And 2 is going to give me 1/4. So when I look at this, I'm going to have -2, 1/4, -1/2, 4. Then nothing at 0. So 1/2, 4, 2, 1/4. So this is going to be an unusual looking function in that the y will always be positive, and the x can never equal 0. So it'll always have to be, remember the quadrants, this one's got to be both your numbers are positive, this one, your x is negative, your y is positive. Y always is going to be positive. So this is a radical square, a rational square, or a reciprocal square function. Yeah, it's got several ways you can identify it. 1 over x squared. The domain for this is, again, that x, we have x such that x cannot equal 0. It can equal everything but 0. Our range will be y such that y is always greater than 0. Okay, and those are our 10 parent functions.